Just over 50 years ago, US President John F. Kennedy was assassinated. He was shot, and he was shot by a man called Lee Harvey Oswald. Since the assassination, many theories have gone round about what really happened on that fateful day. And we will probably never convince everybody of what really happened. One of the questions which never seems to go away is, did Lee Harvey Oswald act alone, or was there a second gunman who fired at the president? Well, maybe a little bit of elemental analysis can cast some light on this question. Now, how many bullets were fired by Lee Harvey Oswald? He fired 3 times. One shot completely missed the presidential limousine. 2 shots hit the presidential limousine. So what we should be able to do is to examine the car and see how many bullets are found. And if there is another gunman, then we would find more than 2 bullets. It's not that simple. Bullets can fragment, they can break up into parts when they hit the target. So when this crime scene was searched, they didn't find 2 bullets. They found all sorts of fragments of bullets. And now the question is, how can we put these fragments together and work out the total number of bullets? It's not a jigsaw puzzle where you can just fit them together and see if they go together, because they deform, and so they can't be just put back together. We need to use some chemistry, some elemental analysis. Of course, the bullets are made of lead. They're all made of lead. So we're not interested in the bulk composition. What we're using is the trace element composition, and particularly 2 of the common trace elements in this kind of bullet, which are silver and antimony. Now, there were multiple fragments found, and these have been grouped into 5. And you can see that the level of silver in these 5 fragment groups is about the same. It varies from the low of 7.9 ppm up to a high of 9.8 ppm. Not terribly much different. But if you look at the antimony concentration, we find a bigger difference. There's 2 groups which have higher levels of antimony, about 800 ppm of antimony. And then we have another group which have only about 600 ppm of antimony. So the most likely conclusion here is that fragment groups 1 and 2 come from the same bullet, which has the higher level of antimony. The other fragment groups 3, 4, and 5 come from another bullet, which has this lower level of antimony. Because we can divide all these fragments into these 2 groups, the high level of antimony and the low level of antimony, it appears that there are only 2 bullets that hit the limousine. And this corresponds to the 2 bullets that Lee Harvey Oswald fired that hit the limousine. Well, it doesn't really prove there was only a single gunman, but it does not give any evidence that there was a second gunman. So the conclusion of the investigation was that it was most likely a single gunman, Lee Harvey Oswald. We don't know the name of this victim. He was given the name Adam by the police during the investigation. He was found in 2001 on the bank of the River Thames in central London. It wasn't a complete body. It was only the torso. So the head was missing, the arms were missing. They had been cut off, and they'd been cut off very professionally with a very sharp knife, and the blood had all been drained from the body. The body was wearing a pair of shorts, and that is it. That is all that the forensic scientists had to work with, a torso and a pair of shorts. And what is remarkable is that forensic scientists, just with that evidence, were able to advance the investigation a long way. Well, the obvious thing to look at is the shorts. The shorts, like so many items of clothing, were made in China. But they were able to track down the manufacturer, they were able to identify which batch of shorts it was, and these shorts had been sold in West Germany. Investigation of the torso involves examining the stomach content, and there were some strange things in the stomach. It contained food. It contained pollen. Now, pollen is released into the air by plants all the time, and naturally a lot of it gets inside us. And pollen, under the microscope, can be identified. You can tell which plant it comes from. And the pollen in the boy's stomach was characteristic of northern European plants. And then there were some very strange things in his stomach. There was clay. There was calabar beans. Now, calabar beans are toxic, and they are not native to Europe. They come from Africa. And there were also gold particles in the stomach. Now, the presence of these last three items is very significant indeed. These items are connected with African black magic. So it was suspected that this was not an ordinary murder. It was believed that this boy had been smuggled to Europe, to West Germany specifically, and then shipped to London to be used in black magic, specifically human sacrifice. Now, what else can we do? How can we further advance this investigation? How can we find out, for instance, where Adam originally came from? And it was elemental analysis that achieved this. We've all heard the expression, "You are what you eat," and it is literally true. Okay, your body is made up of the elements that you eat as part of your diet. Now let's look at bone. Bone is basically calcium phosphate in a protein matrix. Everybody's bones contain large amounts of calcium, and that calcium comes from your diet. And this is why, particularly when you're growing up, it's important to have a good amount of dairy products, because that's an excellent source of calcium. But other metals will also be incorporated into your bones if they are present in your diet. Now, people who live in traditional societies tend to eat food that is grown in their neighborhood, in their backyard, on their farm. That food will contain minerals from the local soil. So if the local soil is particularly rich in a particular element, then the food those people eat will tend to be richer in that element, and this will be reflected in the chemistry of those people's bones. So for instance, if the soil in a particular region is higher in levels of, say, strontium or copper or lead, then those people's bones will be higher in quantities of those three elements compared to people from a different region. So this is what was done. Adam's bones were analyzed for these trace elements, and indeed he had a little more of these elements than normal. Now, based on the idea of human sacrifice and black magic, it was believed that he came from somewhere in West Africa, because that is where these beliefs come from. But West Africa is an enormous place, and there's millions and millions of people there. But the trace element analysis was able to narrow it down. Investigators traveled to different places of West Africa, took samples of the soil, samples of bones, and compared the trace element composition of those samples to the trace element composition of Adam's bones. And that narrowed the search down to a small region of Nigeria. So forensic science in this case didn't identify the murderer, but it certainly told the investigators where they should be looking. So what have we learned in this lecture? We have seen how spectroscopic methods work, whether they are based on emission or, like atomic absorption spectroscopy, on absorption. So we know how they work, and we know their basis in the structure of the atom. We've looked at the EDX technique, which uses X-rays, and we've seen how that can be a very, very powerful technique for forensic scientists when it's combined with scanning electron microscopy. And we've also had a quick look at the technique called neutron activation analysis. So overall, by understanding the structure of the atom and how electrons can move between their energy levels, we understand how forensic scientists can very accurately and reliably determine the elemental composition of a given sample, even to very, very low levels of a particular element. And now we understand how this is a very, very powerful technique.